Hi everyone, welcome back to my channel. Today I am going to solve nuclear chemistry GATE previous year questions. In that, part 1, 2 and 3 video link I have mentioned in description. Please go through that. Now let's move to the question. This has asked in GATE 2025. The question is, an archaeological specimen containing 14C gives 45 counts per gram of carbon in 5 minutes. A specimen of freshly cut wood gives 20 counts per gram of carbon per minute. The counter used recorded a background count of 5 counts per minute in the absence of any carbon 14 containing sample. The age of the specimen is how many years? Here in note they have given T half of carbon 14 is equal to 5730 years. We'll see the solution in step by step. In step 1, convert all counts to same time unit. Archaeological sample 45 counts in 5 minutes gives 9 counts per minute, and fresh wood 20 counts per minute, and background count 5 counts per minute. In step 2, correct for background. Subtract background from both. Sample activity is equal to 9 minus 5 is equal to 4 counts per minute, and fresh wood activity is equal to 20 minus 5 is equal to 15 counts per minute. In step 3, use decay law. Here we use n is equal to n naught e to the power minus lambda t. Take ratio. N by n naught is equal to 4 by 15. Here sample activity is n and fresh wood activity will be 15. Here 4 divided by 15. Take ratio. In step 4, use half-life relation. Lambda is equal to 0.693 divided by T half is equal to 0.693 divided by 5730. Now 4 by 15 is equal to e to the power minus lambda. Taking ln of 4 by 15 is equal to minus lambda t. T is equal to 1 by lambda ln 15 by 4. In step 5, calculate. Ln 15 by 4 is equal to ln 3.75, that is equal to 1.32. So now substitute in lambda. Lambda is equal to 0.693 divided by 5730 is equal to 1.21 into 10 to the power minus 4. Then t is equal to 1.32 divided by 1.21 into 10 to the power minus 4. That is equal to 10,900 years. So the final answer for this question is 1.1 into 10 to the power 4 years. That is equal to 10,900 years. Now we'll see the second question. This question asked in GATE 2023. The choices that correctly identify radioisotopes PQRS shown in the following nuclear reaction is here equation given nickel 6028 plus alpha 4 and 2 gives rise to P, that is unstable. Here you have to calculate n is equal to Q, 2n is equal to R, P gives rise to n plus S. These three you have to calculate. Here options, 4 options given. Now let's see the solution. Given nickel 60 and 28 plus alpha gives rise to P unstable. Step 1, you have to find out P. Mass number is equal to 60 plus 4 is equal to 64. Atomic number 28 plus 2 is equal to 30. Therefore, P is equal to 30 indicates Zn. So 64 Zn 30. So option A is correct. Here given option A, P is equal to Zn 30 64. So option A is the correct one. In step 2, find Q. Here 1 Newton emission given. See, Zn 3064 gives rise to Zn 3063 plus N10. Therefore, Q is equal to Zn 3063. So, option B is the correct one. And next move to the step 3. Here you have to find out R. 2 neutron emission. Zn 3064 gives rise to Zn 3062 plus 2 plus 2. that means neutron 1 and 0. Therefore R is equal to Zn 30 and 62, but option C is equal to copper 29 and 62. That is wrong. Here Z changes, so option C is incorrect. In step 4 we have to find out S. Zn 30 64 used raised to neutron 1 and 0 plus S. Therefore S is equal to 63 Zn 30, but option D is equal to copper 62 and 29, and this is wrong, so option D is incorrect. Yet the final answer will be option A and B. This is the correct one. Now let's move to the third question. This has asked in GATE 2020. The fission reaction of uranium 235-92 with a thermal neutron is represented below. Uranium 235 and 92 plus neutron 1 and 0 gives rise to uranium star 236 and 92. That gives rise to, there are two possibilities. NB 99 and 41, that gives rise to X1, X2 and X3. And another chance is SB 133 and 51, that gives us to Y1, Y2, Y3 and Y4. So 99 NB 99 and 41 and SB 133 and 51 are the primary fission fragment pair which undergoes a series of radioactivity decays to form stable nuclei X3 and Y4. That chain ends. The X3 and Y4 respectively are. Here four options are given. Now let's see the solution in step by step. See, here given reaction. In this, primary fragments are neutron rich that undergoes beta minus decay. Here key concept given. In beta minus decay, mass number A remains same and atomic number Z increases by 1. That in beta minus decay. Then you see in step 1 from niobium 99 and 41. See, niobium 99 and 41 gives rise to molybdenum 99 and 42. Here mass number does not change, but atomic number increases by 1. That gives TC 99 and 43, and that gives RU 99 and 44. That is stable. Therefore, X3 is equal to RU 99 and 44. In step 2, from SB 133 and 51. See, SB 133 and 51 gives TE 133 and 52. That gives I 133 and 53, and that gives XC 133 and 54, and that gives CS 133 and 55. That is stable. Therefore, Y4 is equal to CS 133 and 54. So final answer for this question is option B. RU 99, 44 and CS 133 and 55 is the correct option. Now let's see the fourth question. This is asked in GATE 2016. Among the following, the most stable isotope to radioactive decay is. Here four options are given: 206 PB 20682, 21082, 21282 and 21782. We'll see the most stable isotope. See, given isotopes of PB, here Z is equal to 82. It is common for all four options. Stability rules. Nuclei near magic numbers are most stable. Magic numbers are 2, 8, 20, 28, 50, 82 and 126. For heavy nuclei, N is equal to 126 gives extra stability. Calculate neutron number. N is equal to A minus Z. In option A, PB 206 and 82 gives N is equal to 206 minus 82 is equal to 124. In B, 210 and 82. Here N is equal to 210 minus 82, that is equal to 128. And in C, 212 and 82. N is equal to 212 minus 82 is equal to 130. And in D, 217 and 82 PB. Here N is equal to 217 minus 82 is equal to 135. So close to magic number n is equal to 126. See, in A, 124 minus 126 is equal to 2. 120 in B, 128 minus 126 is equal to 2. And in C, 130 minus 126 is equal to 4. And in D, 135 minus 126 is equal to 9. Among these, 206 Pb is a known stable isotope doubly near magic. Final answer A. Final answer option A is the correct one, that is Pb206 and 82. Now let's move to the fifth question. This has asked in GATE 2026. The sum of the number of alpha particles and beta particles emitted in the nuclear decay process. Here given equation uranium 232 and 92, that gives Pb206 and 82, and here that integer is what? See the solution. Here given equation uranium 232 92, that gives Pb206 and 82. Let number of alpha particle is equal to A and number of beta minus particle is equal to B. In step 1, use mass number A. Each alpha reduces A by 4. So 232 minus 4A is equal to 206. Then 4A is equal to 232 minus 206, that gives is to 26. So A is equal to 26 divided by 4, that gives 6.5. That is not possible but must be integer. See, here 232 minus 20 is equal to 26. A is equal to 26 by 4 is equal to 6.5. This is not integer. Now check carefully. Actually 232 minus 206 is equal to 26. Must be multiple of 4. But 26 is not divisible by 4. Means something is wrong. Correct calculation is 232 minus 206 is equal to 26. But decay must involve integer alpha. So try 232 minus 7 into 4 is equal to 232 minus 28 is equal to 204, close to 206. Hence alpha is equal A is equal to 7. That is alpha. In step 2, use atomic number Z. Each alpha reduces Z by 2 and beta minus increases Z by 1. After 7 alpha, Z is equal to 92 minus 7 into 2 is equal to 92 minus 14 is equal to 78. To reach final Z is equal to 82. 78 plus Pb is equal to 82. So Pb is equal to 4. Final answer A plus B is equal to 7 plus 4 is equal to 11. This is the total number of alpha and beta particles, that will be 11. This is the final answer. We'll go to the sixth question. This is asked in GATE 2006. 1 gram of 90 strontium gets converted to 0.953 gram after 2 years. The half-life of 90 strontium and the amount of 90 strontium remaining after 5 years are here. 4 options are given. Now we'll see the solution. Here given initial amount N0 is equal to 1 gram and amount after 2 years N is equal to 0.953 gram. Time T is equal to 2 years. So use decay law. N is equal to N0 e to the power minus lambda T. In step 1, find decay constant lambda. See, 0.953 is equal to 1 into e to the power minus 2 lambda. Here e to the power minus 2 lambda is equal to 0.953. Taking ln minus 2 lambda is equal to ln of 0.953. Ln of 0.953 is equal to minus 0.0488. So lambda is equal to 0.0488 divided by 2 is equal to 0.0244 per year. In step 2, we have to find half-life. T half is equal to 0.693 divided by lambda. Therefore, T half is equal to 0.693 divided by 0.0244 is equal to 28.4. That will be equal to nearer to 28.8 years. In step 3, we have to calculate amount after 5 years. So use equation n is equal to n naught e to the power minus lambda t. So n is equal to 1 into e to the power minus 0.0244 into 5. So n is equal to e to the power minus 0.122, that is equal to 0.885 is equal to 0.887. So final answer is the option C, 28.8 years and 0.887 gram is the correct one. I hope you understand this concept. In next video I will come with some more questions. If you like this video, please like, share and subscribe to my channel. Thank you. Have a good day.